So that was the third question. And the fourth question was it was based on an example I did in class. It was the example of an FEC scheme called the repetition code. So 3 repetition code. This maps a single 0 to 3 zeros and a single 1 to 3 ones. I explained in class that you can correct one channel error using this scheme, because if you send, let's say 0 was sent, and so before sending, your FEC scheme will map this to 3 zeros, and this is sent over the channel. And your channel can introduce errors. So let's say 1 bit error happened, one of the bits flipped, then let's say this was received. Then the 3 repetition code, it will use majority decoding, that it will see 2 zeros and it will decode this to, so it can correct 1 error. Similarly, the 5 repetition code, it maps a single 0 to 5 zeros and a single 1 to 5 ones. This can correct 2 errors, because in the same example, let's say I have 2 errors. Now again I can do majority decoding and see that the number of zeros is the zeros are the majority, so what was transmitted was actually 5 zeros instead of 5 ones. So you just do this. Now this scheme cannot correct 3 errors, because suppose 3 bits were in error and what was received was this, then the majority is 1. So what the decoder would make the mistake and it would think that this was transmitted. So this was transmitted, so it will guess that actually 1 was the information which the sender or the source wants to send. So this can correct at most 2 errors. And that was what I explained, that these two facts were mentioned in the question. So my question was, how many bits can a 4 repetition code correct? So if you have a 4 repetition code, so a 4 repetition code can map a single 0 to 4 and 1 to this thing. So now let's say 1 error happens. The majority is still 0, the number of zeros are still majority, so this will be decoded to all zeros. So this is fine. But let's say 2 errors happen. If 2 errors happen, then neither of the 2 are majority. So there is an ambiguity. You don't know whether actually what was sent was all ones and 2 bits were flipped, or it was all zeros and 2 bits were flipped. So in this case, I cannot say with certainty which one what was actually sent. So 2 errors cannot be corrected by the 4 repetition code. So the answer is it can correct a maximum of 1 error accurately. So the answer was 1 error. And most of you got this right. It was either if you attempted the question you got it right, or people who did not know did not attempt the question. So that was part A of 4.